Interesting. Okay. Well, it's been a time. Been a while, I mean. I've been working on installing, or yeah, well, the README basically. You have to go to the branch brain, and down here you have a better overview of how to compile this thing. I should probably merge it with master, but I'm still not happy that it totally doesn't work. So the branch brain stands still for open brain surgery. And yeah, I don't think that's finished yet. The patient's completely died. No blood left, but he'll continue. Yeah, so okay. Been working on documentation on how to configure and compile it, and I completely forgot what I was doing in the C++ department. I am having, yeah, this is what I added. Guess I should add that as well. Let me add what I did for Ubuntu basically. Git add -p. Yes. So now I search if C is installed, and if not, then I add it to Kitash. Wait, let me quit. Status. Got to add this one as well. Goes with it. Yes. No. Then this is also a yes. So if Gitash installs something, it sets, well, if you install foo, it sets foo root. But turned out that package check models is not picking that up, so I added this. Added to the CMake prefix path, if it exists. Well, if it does not exist, it's empty, and then this line doesn't do anything. And this way it works. Hello. So basically no to every C++ change. Yeah. I mean, let's just say no to everything. I already have it. Okay, so git diff cache this now. Changes that are needed in order for the readme to work, so I better commit it as well. Support for configuring on Ubuntu. Well, Debian. Well, Debian wasn't tested. Ubuntu. See readme.md. Yeah, and now we can continue for real. So currently we have this crash here. Segmentation fault. It's not core dumping or asserting, I think, which is a real crash. So I'll have to look in the debugger what that is. And it crashes on, I bet. This being null. P would be nice. 08, well, that's as crashy as 0. Basically we don't have a new device size start. L minus goes up, so we can see where's that thing come from. Usually not clear at all, so I just do a few L minus and then I start doing L's, and now we have all the source code. Where did it crash? Line number 199. Yeah. Okay, I got this just wrong, I guess. I never tested it, so I just typed it like this and I thought it was okay. Or mdata 0. Yeah, looks okay. How can it be in the 08 then? Wait, oops, am I completely idiot here? This was the wrong value. It's 8. That looks extremely unlikely. What is binding count? Binding count is 1, size of buffer. I don't think it can print it, but hey. You never know when GDB grows up. Oh, 8, okay. So this should be mdata plus 8. Yep, and it is 8, I think. Oh, I'm adding it to mdata before setting mdata. Yeah, that would do it. Okay, I'll have to swap these two lines. Quit. mdata is defined here. So realloc. No, wait a minute. Oh, yeah, okay. Well, we begin with mdata 0 and then we do a reallocation because we need space, which either moves it or... just nonsense. Has to go there. So the idea is that we have a memory block pointed to by mdata. Let me fix this a bit up. Control V, Y, P. Mdata. Well, that was not enough P's. Mdata. And I put this one to the other side maybe also. Buffer end. Need even more spaces. And 1, 2, 3, 4. So mdata points to a block. I don't know when it is clear because I made it up. To me it's way more, it's sooner clearer than to other people maybe. So I think, well, let's add this. Maybe space more. The minus here. data points to the beginning of this block, and it doesn't contain pointers. It contains actual buffers, objects, and device size objects. Often I need a mathematical big agulade. I don't know what that is in there. 1, 2, 3, 4. Yeah, it's a bit vague. How do I do that? So I'm gonna find it again. I don't know which. I think I used it in UTF-8. I'll just search it. Multi-line or something. Multi-line brace or brackets. Well, nice list, but I don't see them. This looks a bit like it. Oh, we don't have the closing one. Oh, a few more rows. Right parenthesis lower hook. Yeah, that's what I was looking for. So we need this, but then pointing the other way. Oh, they're all in the found it. So let's put that here then. This one. Oops, not that one, this one. I guess this one. Yay, awesome, isn't it? So that would be binding count times size of device, no, size of buffer, bytes. And then here I have binding count times the size of device size. Bytes. Don't forget punctuation. It's an English sentence. Okay, so now it's clear, I think. And that's not true. We're going to insert, now let's call it append, one VK buffer and one VK device. So we do increment binding count, is logical. You get one buffer more, we get one device more. Then I reallocate this block to become the new binding count times size of buffer plus size of device size. Also totally logical. Then we have the new device size start is mdata plus mbinding count times the size of buffer. So that's going to be, you know, this one, the new device size start. And now here I call it buffer end because I never updated it. I think it speaks for itself. After the realloc, we need to move the VK devices, which are no pointers. You need to move this whole block here down on up to make place for the new VK buffer. So move minus size of VK buffer. That's where it is now. And we move only binding card -1 because we don't have any more. And then we do reinterpret cost and data as an array and binding -1 new buffer and device size as blah blah blah. Okay. Yeah. With updated documents. Congratulations, Fatman. You're no longer a virgin. Oh wait, you said something before that. Maybe I got the context wrong. I got my calculator all exam and I got extra 13 hours. Well, you already know everything, or you should be studying / sleeping. Yeah. I don't know, linear algebra is super easy, but you have to, you know, it's linear. I don't know what they do. What do they do? Vectors and stuff? Or also matrices? In products, out products? What else is there? I have a hint. Take your textbook that you have to learn and then flip over the pages and make a cheat sheet. Now you cannot bring the cheat sheet with you, but I guarantee you it will help a lot. Pretend that you can bring the cheat sheet with you and make it. And then tomorrow you won't need it because if you write it down like that, it's in your head. Structure tests. Now we crash somewhere else. Or not. Aborted this time. There's the abort. This is the line where it was aborted. That's not a bad abort. It just says I have to implement something. Yeah. I totally forgot everything again, what I did, what I was doing. So it's like, okay, what is this function doing? Why is it not implemented? Oh my god, a big one even. So non-productive. Getting everything. It's being called from... Yeah, from here I guess. Okay, I guess it is being done for every fill index whenever all the characteristics have been pre-processed. And if I look at, for example, this first function, which is still working, it clears the target and then copies from one thing to another, to that target. And then it said, it changed something. Oh no, I hate it. Yeah. What about this one? Also not. Yeah, these also have changed. Okay, so they're being called and then they're being efficient because they don't do anything unless that is change is being set. As far as I know, I removed that is no longer being set. Well, it's set to false, but that's it. No, it's just not being used at all anymore. Why did this even compile? What? Oh, it compiled because this was commented out. No. It does not exist anymore, this changed. Now, why was that again? Okay, this one is cleared, so I have to copy something to here, I guess. Yep. So add vertex shader object is responsible for filling these two. Vectors. Okay, that's one. That's another. And that can't be right, can it? Because this is window.h. Frame resources. Yeah, this one. Add vertex shader. These two vectors, yeah, they will be filled by add a vertex shader. That's what it says here. But we don't do that anymore. And this is, I guess, in the other function that was commented out. Yep. And this used to be in the user code, but no, and not anymore, which is only good. The less user code, the better. It's now in the engine being done basically here with add to flat create info doing calling add on the flat grade info object. Nope. Descriptions, well, I guess these two. So one of the adds is this, and the other add is this one, which then causes it to be added, the vector that is, to this list and this list respectively, and then later when we call merge, we read it out, we read it back again here and here. So that would be when this is being called. Which is being called here. And then we use that to create a pipeline. Okay, so just refreshing my memory. So yes, we definitely have to do this, clear, and then fill it, but with what? Now get this old code, and this reading stuff from here. Alright, I moved that one to vertex buffers. I would say that is already filled, isn't it? Yep, here. Also guessing the type is still the same, but let's make sure. Change is not interesting. Printing it, here's one. This is the type. The index not interesting. It is a pointer to a vertex shader input set base. That's what it was. Don't see the new file. So yeah, still the same thing. Now well, the code can virtually be the same, except that I have to get it from a vertex buffers thing. I don't know where I did hide that. Apparently my vertex buffers is an element of my window class, aka the application, the user application. So we need access to that thing. No idea how. Maybe the create vertex buffer. Okay. Where's it being called from? The code that we just looked at. It's not this file. No, here's the pushback. It is being filled by the call to create a vertex buffer. I think the idea was that you can create multiple vertex buffers, and the vertex buffers are more or less independent of pipeline factoring. Except that, you know, at some point you bind them. So this thing is being bound. Here. And that only works when the pipeline has knowledge of the layout of whatever you're trying to bind here. So we could do m vertex buffers 1 and then bind that, or m vertex buffers 2 and then bind that, but they need to have some similarity, so I can use one or the other. Cannot use an absolutely random thing. Shot count. Still keeping count. Yeah, okay, Omnic. Omnic has lots of work to do. That's a good thing, I guess. Okay, I have to think about this again. What was it? What exactly we need or want? I think that in the previous code, those has changed things. Get diff again, I guess. That was set to true every time this is being changed. As a result of calling add vertex input binding. Because, well, I never knew if it was called and or how often. On this way you can do one or more calls to add vertex input binding, and then we would have to regenerate something because this has changed. Or this one has changed. But I believe this now happens before the pipeline factory even runs. So we already did all this, and there is no need anymore to have a boolean changed because all the data is there at the moment what we want it. That's my guess. We can check that, you know, like search for this in the current code. Happens now here. As a result of a call to create vertex buffer. Yeah, let's already see it coming, right? That was called here. From create vertex buffers, which is being called from here, which is definitely before the factory runs, isn't it? Yeah. Even before the shaders are known, so totally. So that has already been done and all that information exists. Therefore we do not need the booleans anymore, but where is that data then? And which of the many vertex? I only need one, but how do I get that? Let me look again. This one. So in this case you only have one object, vertex buffers. Oh right, yeah, I do need to pass that somewhere, and I do. And I'm not doing that, but I should. Okay, so let's point out where it goes wrong. Already delete that. Already deleted that even. What? Oh, I deleted it. Must be in the div. Let's look for what I deleted. No, cannot be called vertex buffers. Okay, I think. Oh, this. I was looking for vertex buffers, but you cannot access this. A private variable. That's the thing that I need. GPS. Yeah, I'm just calling the function vertex buffers here. That should, well, that tells the engine, should tell the engine that it is this vertex buffers that we want to use. Fix me, is this the right place to call this? Yeah, maybe because I might want to change halfway. No, you cannot do that. Or can I? No, why not? This is creating, we get here once for each pipeline that we create. Every pipeline theoretically could use a different vertex buffer, so... Okay, yeah. Maybe, maybe not, I don't know. What is it doing? What's it currently doing? Nothing at all. See, that's why it doesn't work. Right, so we get here with a vertex buffers. And I think I should just set, this is the add vertex shader, so I can just set a variable here. It's called current vertex buffers. Object. I have to add that, and what shall I add? Well, I think vertex buffers is just a known class, not even derived from something, so I just add a vertex buffers pointer to add vertex shader. Vertex buffers vulkan, right? So you are in vulkan pipeline, and that must be a const pointer. And let's begin with initializing it with null. Well, if it's yeah, it's a style. Never mind. So that now is being set. I still don't know the fix me, so I'll leave it in. I have to think about the threading as well. Race conditions. The first time we set it, we are happy. The second time we set it, we override something. Is there a problem? Can there be a problem at the moment that we override this value? It shouldn't be, but I have to check how boring that is. Check from here. So the add vertex binding is being called from initialize of some characteristic. That's pretty random. But okay, it's a initialize of some characteristic. Yeah, and when do we use it? We used it in... Well, we are going to use it rather in this function here. So when this is being called, we're going to use it. That would be from here. Well, that happens when all the characteristic ranges are pre-processed. So that's totally different than initialized and after initialized. First you get initialized, and then we get filled, and then we get pre-processed. So we definitely already passed the initialization phase here. Actually, it's kind of weird there, because if we call it only during initialization, then why would I do it multiple times during fill as well? Man. No, it was just over there. Who cares? No race condition, so that's okay. And then we can use it here. Our new thing here. This. However, yeah, it's an update of Vertex input binding descriptions, which depends on whatever I have now. I'm going to use that very pointer as the boolean, because it was a null pointer, and we just set it. So what if I just use it and then set it to false again? Well, to null pointer again. But we have to run over this for each binding. I don't think it's related to IQ, it's related to memory, unfortunately. Well, maybe. If you want to write a difficult program like I'm working on now, then you need to have a, you know, a certain state of mind in internally feel for the whole complexity of everything and all the associations between it, which is so much that you cannot catch it in words. And if you can do that, then I suppose you automatically have a high IQ maybe. But if you can't do that, then just write simpler programs. I mean, plus, you know, what I'm doing now I'm getting older. Lots of documentation, separating stuff in little chunks. I used to write no documentation, have no clear variable names and class names, have no structure. And I just remembered everything, so I didn't need it. But if you need it, like me now, even I'm even past that point, I think. Sometimes I wonder if I shouldn't stop programming completely. But that's probably the end of my life then, when I do that. I wouldn't know what else to do. Plus, yeah, if you feel comfortable, you're not learning anything. I heard last someone say on a YouTube video, and I totally agree. You must feel the pain, non-stop pain. And then you slowly, extremely slowly, you'll make progress. That's normal. So that's why people watch my stream, to see how it really works. You know, if you look like at the sexy models in magazines, then you think all the people are handsome. That's not true. And if you look at YouTube tutorials, then you think that, you know, aha, those people, they just type it in and it works immediately. That's not how it works. It's a painful process. I was thinking about making this a lambda and just, you know, leaving it to the vertex buffers object here to do its thing. I could ask it to call a lambda where it passes the binding and gives me back a pointer to a vertex input set for all the things that are on. How about that? So we do this, and it's a pointer, and I say for each vertex input set. Let's not abbreviate anything. And on the pass a lambda, that is yeah, well, just capture this. Let's not make it difficult. And I want to have passed the type of vertex input set, which is a bloody auto here. Why? Vertex buffers, no. And vertex shader, what? Vertex buffers pointer, really? I don't think so. Hold on. And that. XC tags, and now cannot find back the file that I was in because it had to complain about something. Otherwise you charge VI, but no, the last error here. Oh, you did not save that. Yeah. So where was I? I was here. Okay. Now I should be able to jump to it. And that's the type. And that's the index. Now I have. Okay, so our lambda is going to return both. It totally doesn't fit on my monitor anymore. Just have to do it like that then. And then this is being called a vertex shader. And it could be a const, so why not? Maybe it has to be anyway. And this is my binding. So, there we are. So now this is, it doesn't exist yet, but I'm going to write it such that it's going to call me back for every vertex input and binding number. And then we can just copy this code. Binding. Our binding is no longer an uint, as you can see, but well, it's just, that's what it should be. So much better. This is the same type. And then setting that to 0. So this whole thing comes in here. And plus binding is obviously not needed because that's being incremented for me. And well, this must be an uint, so I'm gonna say get value, and then I get size type. So I have to static cast it to uint 32 type. I think that looks beautiful. Now this remark here is nonsense because we only set it once during initialization. So it's just nonsense. It's total nonsense. In fact, it's so much nonsense that I'm gonna add a fix me. And I'll even make it worse. I'm going to add an assert that the thing is set. So if you being called for the second time, then it's gonna assert there. Whoops. But hey, that will force me to fix the fact that it's now being called many times. And I really don't think that should be, but I don't know yet. Anyway, let's add the assert here. So if you don't set it at all, of course I don't know anymore where I was setting it. What? Oh, so annoying. It's the same file too. Oh, de oud papier buiten zetten. Just so you know it. Maybe I could do that. No, I have very little old paper. I think I still have room in the carton box that I put it in, so it's not necessary. Yeah, with a compatible, I guess. Then it should also say from where it should be called, but I don't know yet. Add another fix me. I hate fix me's, but better than no documentation. Painful thing, it is add vertex channel, so it definitely has to be called from characteristic. We'll see. Okay, so that was one. The other one is way more problematic because I had not taken into account, I think, that I need this as well. Oh. Or oh no. That's being cleared, and then wait, it's not looking at it yet. Let's first implement this thing here for each input send. I'm going to just copy this, I guess. Pseudo memory. And then this thing is the type to which I have to add it, and the type is vertex buffers, and it must be a public function, and that's being done after this one, so I should add it here. And then there's a void function. And it takes a standard function of well, a lambda, and I might as well implement it in the .cxx file. And the function that the signature of the lambda, well, I don't think it returns anything, so it's also a void. And then we have this is type, comma, this is type. I'm not sure I put a space here. I think I high exception. I do not. And the namespace we are in, I say the bullet must be added. Vertex buffer. Binding index is in just in vulkan. Okay. I call it lambda, or shall I just call it callback? I'm gonna call it CV. Oh no, an abbreviation. But that's because I'm not interested to ever find it with a grep. And then yeah, unfortunately my opinion about ChatGPT is such that I don't think that will work. It's so full of shit, really. I hardly get any answer that is even remotely useful. I pasted it in Discord, I think, my chat, or I asked some mathematical thing and it thought that 40 was odd. And I say 40 is even. Oh, you're right, I'm sorry for my mistake. 40 is even. So instead, we'll use 4. And it just tries a random number, absolutely random. So 4 is also even, 50%, 50% chance, right? And then I do some calculations, which actually were correct. I mean, it had to multiply by 3 and add 1. It could do that. And then it said, which is a power of 2? What was that? Is equals 22, which is a power of 2. So I'm like, sorry, no, it's not a power of 2. Oh, I'm sorry for the mistake. Yes, you're right, 22 is not a power of 2. So then let's try, now I picked another random number, calculated that, the result was something and that was not a power of 2. Therefore, I cannot find, and thought, wow, it's going to, what is it? It's going to admit that it cannot do something. No, I cannot find the answer because there is no solution. Which was, it just proved that there was no solution because it tried one single random number. And they said, well, I know the solution, and there are infinite number of solutions. You're just trying one number. Network error. Really. The thing is so stupid, it's completely unusable. Yeah, that thing. Okay, we have to do the callback. No, we have to run over something. I'll just use the full thing, I guess. I don't have any names here. I'm binding, and this was Vertex shader input set. No, doesn't fit. Yeah, let's put this there. Also doesn't look very nice, does it? Should I pass standard function as is, or by value I mean, or as a const reference? I think standard function is like 24 bytes or something, 48 maybe, but I guess since I'm constructing it from a lambda, that it doesn't really matter, but on the other hand it's not inlined. So pass it over the stack, right? We do that. Hey, my favorite moderator, Demir. Yeah, Demir had to do some studying, I think. How's the study going, Demir? Are you finally finished? Like, really finished, so you can start helping me? I remember something like that. I keep confusing all those moderators. But it's just my memory. So, don't take it personally. Yeah, that was nonsense. This was nonsense. Sorry guys, it's nonsense. It's just a type. It's a good thing. Now it fits on one line. And then we do the callback. Okay, still have to run over it. How? And this is vertex buffers. And my function off. Was going to run over. What the hell is this? Now I'm back here. Okay. I wanted to run over this thing, right? Yeah. To copy it. Since you also need a binding, I think I might as well run over the binding numbers, the index numbers. But yeah, what it returns now is a pointer. Okay, that's cool. I needed a const pointer so that will work, and we have the binding number and everything is good. Should be. Let's check if this compiles. I'm looking at what Mark Poe said. You also said what your IQ was, which I forgot, of course. Yeah, you said my IQ is 106. I don't think it is 106, I think you have more. I mean, someone with an IQ of 106 would just not follow the stream, period. And they wouldn't type uppercase at the beginning of sentence and use punctuation like you do. And so apart from that I think your IQ is much higher, I disagree that someone with a IQ 100 can do anything anyway if he just puts effort into it. At some point there's really a limit to what you can understand. Which I think has to do with, literally the connections in your brain, the neural pathways that you created. So, of course you can get a lot further in a certain topic if you have a really good teacher who takes all the time to repeat and explain, and you know, I've made puzzles for, well, in the subject that I excel in. I've been tested at high IQ, I said it before, but let's not repeat it. I've done a lot of other tests which were, I usually score like off the scale. The highest thing that I really scored high for was spatial insight. Literally off the paper and stuff. So I prefer to make puzzles that are require you to think in multi-dimensions or infinite dimensions at the same time. Something multi-dimensional. So say I have a puzzle which is two-dimensional, I extend it to 3D, and if that's still interesting, I extend it to 4D and then 5D, and then I make a puzzle of it. And then I ask people to solve it. It's evil. I could give an example, I think, but it's probably, it does require knowledge of some mathematics, even though you can think of the major insight does not really require mathematics, but the final answer does, unfortunately. Not more difficult than what I did during my college conjecture stream, but still. And that is an extension of an existing puzzle. And it goes as follows. Imagine you have n-dimensional hypercubes. I assume you can look up what a hypercube is, or you already know it. Of course, you can stack up hypercubes in a hyperblock, as it were. So if you have n dimensions, and you can make a block of a times b times c times d, etc., and then n times. So let's say 3 times 4, or 3 by 5 by 8 by 7, yeah, something like that. And then in total n. And now we color the outsides of each hypercube with a color palette of k colors. So each outside, all the points that are on the outside that touch the hypercube next to it, which are n-1 dimensional hypercubes. So you have two n-1 dimensional hypercubes on the outside of each n-dimensional hypercube that can touch the other n-1 hypercube that's on the outside of the n-dimensional hypercube that's next to it. And we paint those outsides in colors from a palette of k colors. And then the question is very simple. Find a formula that gives you the number of possible permutations to paint hypercubes in for a given dimension n and the number of colors k. Yeah, tesseract I think is 4D cube. Oh, we're talking about n-dimensional. So one-dimensional would be just a line piece, length 1, say. 2-dimensional is a square, 3-dimensional is a cube, 4-dimensional is a tesseract then, I guess, and 5-dimensional, and it just gets larger and larger. But the idea is really simple. I mean, you just have, for every dimension, it's the same as 1 dimension. So we have a line piece with 2 edges. And if I put another hypercube next to it in that dimension, so this is then one of the dimensions, say the x-axis. Then they touch on one outside, and they have in total 2n outsides. So if you have 1 dimension, you have 2 times 1 is 2 outsides. If you have a square, you have 4 sides. If you have a cube, you have 6 sides. It's 2 times the number of dimensions. More importantly, I think you have to think about what is permutation. Well, permutation is you are allowed to rotate them in n dimensions, but not in n+1 dimensions. So you cannot mirror them. So say for normal cubes, they're just dices, and you can rotate them like a dice in 3D space, but you cannot mirror them. And then if, say, you have two cubes that are painted, and despite the rotation, you can never rotate them such that they look exactly the same, then they are different. And then the question is, so how many different cubes can you make? So you would have, say you have two colors, then you have a cube that is all yellow, you have a cube that is all green, you have a cube that's all yellow except for one face, which is green. You have your cube that is all green except for one face, which is yellow. And then you have, I think, two cubes that have three yellow faces and three green faces. And you have two cubes that have two green faces and four yellow, and also two cubes that have four, well, the other way around. Yellow, green swapped again. And you sum it all up to f of n, so it was for 3 dimensions and 2 colors equals, I just said it was 1 plus 1 plus 1 plus 1 plus 2 plus last one, I said 2, right? 2 plus 2. Yeah, totally. So the answer is then 6 plus 4 is 10. But you have to, the question is simply that, you know, what is the formula for, how can you calculate this for arbitrary n and k, so fn comma k. And it's not a super simple formula. I'll even give you that. It contains binomials. But the real problem is to have that one inside. That aha moment that you understand what the trick is. Took me 2 weeks. I found it while I was biking, so you can do it from your head. But still, not easy. I didn't even look at the bloody error here. In memory function virtual blah 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 passing const vertex buffers as this argument discuss qualifiers. Yeah, it's const, totally const. So it really helps not to look at the chat and or concentrate despite it. I don't like this large font, but I'm gonna go with this. Maybe it's a, wait, what the, wait, this. That's put each argument on its own line. No, that's not, this is a single argument. Arg. I'll leave it like that. Yes, of course. I just said you can do all green, all yellow, etc. I made that puzzle especially because, well, that's not a story which I probably should not tell. So let's not tell it. Anyway, I made it in the past, and then I added to it that I thought that it would be possible to solve it in half an hour, sitting in a chair with your eyes closed, if you had an IQ of 200. So don't think that you can just answer it in the chat. It's gonna take you a long time if you find it at all, because I did not find anyone who found it ever. Except one person. So it's not ever. One person did find it. But he kind of cheated, because I was a mathematics teacher who used higher mathematics to find the answer, I think. Oh no, wait, that's another puzzle. No, that was another puzzle. This one, no, nobody found that. Which I guess nobody tried for 2 weeks, you know. Most people try it for 15 minutes and then they give up or something like that. Yeah, distracted. Core dump. It doesn't core dump, that's one thing. Can assume that it works then, right? No. Doesn't say much that it does not core dump. We have to implement this one too, and then maybe there's a hope for some sensible output. As in that it actually shows us something. I don't know, we'll just have to continue, I guess. Yeah, this one is very much like the previous one, except that I do not think I even have this information yet, because this one is being filled from that. Is that the only input? Yeah, no. Let's check. We clear the run over that vector and then Vertex shader location context. Yeah, I don't think you can find it, Post Bunny. Like I said, the actual answer is unfortunately not super easy, and it contains binomials. But what is it called? Combination theory or something like that. I mean, just the mathematics that has to do with permutations. So, how many ways, you know, can you pick 3 balls from a basket of 10 balls, stuff like that. Combinatorics or something like that. If you know that, then the mathematics is easy. No, of course not. No factoring polynomials. Maybe binomials, so literally written as n over k or n choose k. So the answer is how many ways can you choose k balls from or k things from a total of n, if the order doesn't matter. So that would be a binomial. So I do feel that I give away something with telling you that. I should not have even told you that binomials are the part of the answer, but okay. Yeah, I'm gonna click on a different tab. So no chat for me for a bit. I'm having here that thing as input. You also have inverted location context. Oh no, oh no. Do we have other inputs? Even more? And that's the output. For Vertex attribute ether, which is converted to that. Yeah, no. I only see two inputs, where one we already knew, that was the one at the top, but this one, where does that come from? Just to get a location, which is then used here. Okay. Well, I guess we have to look at both. I'm gonna start with the location thing because that is surprising me. That is also stored in the add vertex shader. Yeah, that returns a non-const pointer, so I guess this is how it gets filled. Called from vertex attribute is used in. Okay, so this is that thing is being filled magically, I suppose, by pre-processing it. So I won't worry about it. It should already be should be filled with the correct stuff then. At the moment I'm getting here, because this is again called from something that comes after that, after pre-processing. Yeah, everything is pre-processed, so that thing should already be filled. And I'm only worried then about data that is used. I'm actually still worried because preprocessing only finds variables that are in the shader code. Everything might not be in this first shader. So that would not be entirely filled. What does that mean for the content of this? See, this thing here contains everything. Oh, it does do a continue in that case, but it's still printing a warning. I think the warning comes from the fact that I would not expect it to exist in this vector if it does not occur in the shader code. So the pre-processing doesn't find it, but it's in here, and the warning is basically about what the shader code is not containing that, and you still added it to that thing here. But I think I made the change now that I'm adding everything to this that it's needed for any pipeline of the whole pipeline factory. And then certain shaders might not contain the things that I have added already anyway. But I feel confused, as usual. Or maybe I don't even know when I'm filling this. Maybe this thing should be filled, one pipeline at a time. Then the warning is correct. Yeah, I should definitely have a look at where I even get this data from. If it still exists, if it is filled. Whoa. Well, yes, I guess it can be removed then, because I have it here now. In fact, since it is commented out, maybe I should start with removing it and then see if it's not already removed. I don't see it anywhere else. If it is in shader stage, it would be, this is a comment. It's already removed. Okay, make sure there's a comment, this is a comment, this is not a declaration. There's a comment, this is in vertex buffers, everything will that matter. Seems the answer is yes. But it's still in a comment. Let's see what that comment is saying here about it. What? Pipeline factory? Dealer's ID to shader resource is now defined in. Yeah, I moved it here, I guess. Okay, alarm. We have multiple vertex buffers, potentially. So which one then? All of them? That's not going to be possible. Not good. Apparently, if I'm filling this, then every time I add something, I also add it to shader variables. No, I didn't. I remember that. That has been commented out. We are not adding it to shader variables anymore. But it should be. So you're going to run into a problem there, and then I'll figure it out, I guess. Then this comment might not be entirely correct, but well. I didn't eat yet. Who can heat up some pea soup for me? I should cook. Why am I not cooking? Okay, what was I doing? Here's an insert. There's another insert. Yeah, close inserts. I remember. I think, yeah, this is just the add vertex attribute, which are now being called from here. So it's really that thing that's doing it. Which again, well, exactly like the other, is called only once. And this was commented out. Shared variables. But this thing is then super equal. It's just being filled already, just like the other one. Great grandfather. No, wait. just great. What shall we do? What shall we do? I was editing probably this or something. No, can no longer use that pointer then, because I mean can no longer set it to 0. But well, if I set it to 0, then either it wouldn't do anything or we would assert. So as long as it assert is here, I can remove this, I think. And then I can just copy this. Which means the whole test nonsense as well, because we just really should not call this again. Let's just call it once. Okay, now add vertex shader is still the one that owns this object, right? Yep. So well, but I can pass that, I suppose. No, we can do the same thing. Just we'll just make a huge lambda here. Maybe it's kind of silly to use a lambda. I could just, you know, get I could just get this vector and then run over it myself here. Because, well, this is going to be a huge lambda and it starts to look silly then, I think. Yeah, I don't know. I don't like it very much, I have to say. I mean, if you just add accessors for everything. Also, the code should go in objects that, yeah, it kind of belongs to. So I feel that it is pretty logical to have a for each vertex input set, because the vertex input sets are stored in they are stored in well, in this vertex buffers. Okay, I'll keep the lambda for now. Did I make that typo elsewhere as well? For each. Yep, I did. Yeah, I don't know. It's really it depends on your mood. I'd say so. Both are good methods. I'm just still, you know, this is also a bit weird to pass these two. Well, this is just the element of that index. Yeah, anyway. Okay, so I'm kind of like indecisive about this one, which means that in this case I really don't want it because it's even worse. The lambda would be way larger. So then I guess I'm just, you know, going to make an accessor for it. Or I can add the interface that I need to that clause. Maybe that's better. The interface that I need would be an I begin and an I end for each. It also feels a bit silly, I have to say. Now let's not do that. Yeah, well, if I add accessors, and I guess my using types must be public. And then we'll have accessors for this. Just copy this. Instead of the for each. Thought I had implemented that. Vertex. Hello, wake up. Vertex input set. Okay, I'm going to delete this. In fact, I do already not have it anymore. And I'm going to need this and put that in the other file. Which other file? This one. So I compile it first and see if we only get an error in this function. Nope. Oh, that's the same thing. Well, then make a local. Then let's make a local. I'm still using auto here. I know it's horrible, but okay. So that kind of works then, and then I can, let's make a double text again. Now I want to run over the other one. So we made what? I want this one. Is this a binding? I don't think so. No, it's not a binding. Definitely not. What is it? I have a binding here, but this does not come into play here. I just have an iterator, no binding necessary, I guess. I mean, not the index is not important. So, let's just run over all the elements then. Gonna do that. Yeah. No, we really need to know what is in there. It's a map. Oh boy. Yeah, let's use iterators then. Let's use iterators. I can still use auto, but just by value. It's an iterator. Okay. Yeah, okay. Hardly necessary to create this local then. But let's do it the same as we did up there. And the rest should compile already then, doesn't it? Up to the next problem. Yep. shader variables is empty. Loads and loads of chat. I thought, well, let's click on chat again. My god, that's almost too much to read. When did I leave the chat? Yeah, let me read the chat. I have a few minutes. Yeah, the question, advice for new coders. I have had that question so often that I really can't answer it anymore. I guess I should add it to the FAQ or something, because it was asked a lot. I'm not impressed by ChatGPT Mark Post. I mean, so far it's only telling me absolute 100% nonsense. It's very self-convinced. What is the word? It answers like it knows, but yeah. 40 is not odd. Sure about that? Yeah, fat man, you should go to bed if you weren't already, because that was 15 minutes ago. I don't think Mark Boy is talking to me, so skip that. Okay, up to date. The reason that we are not compiling here is because I do not add my variables to shadow variables. And with shadow variables being empty, it doesn't find this, or this, or this. Oh wait, did find that one. Doesn't find these two, so yeah, no substitution takes place, and therefore the double colon remains in the code, which isn't GLSL, so it errors out on that. To the next step is clearly that I have to add stuff to m variables again. Shader variables. Variables, I think, yeah. In other words, that fixed me here. How do we do that? And I'm hungry. I didn't eat. I'm going to make pea soup, guys, because otherwise I'm going to bed with a stomach full with pea soup. It's not good. And I should give my eye rest anyway. I'm starting to think that maybe my eye is complaining with the double image because I'm looking to screens too much. Always focused on the same spot. My bloody lens. Yep. I thought it was the layer on top of my eye, but now I'm starting to think that it's my lens. So that's bad. You can never fix that, I think. If I try to focus, so the shape of your lens changes. Try to focus, and I think that a part of my lens is no longer as flexible as the rest, which unfortunately is I think called star, the beginning of. Well, they're talking about operation. So you try to focus it, and just, you know, the lens is not really flexible anymore. Not good. You're already talking about troubling. I don't see that yet. Double Z. I'm afraid it is the beginning of this. Good. So I thought it was this part here, but I'm afraid it's a lens. I'm not sure which lens. I thought there were two lenses. I only see one here. And I guess the lens that I changed is shown. So it's possible to have an operation. What I do is if it is super normal. Well, not happy with it at all. But yeah, I'm going to cook dinner, so I'll be back tomorrow, I guess.